Hi, welcome to this video. Hope you guys had watched my first video which introduces you guys to Pascal's triangle. If you haven't and you're not so sure about what's binomial expansion or what's a Pascal's triangle, you might want to watch that first. Now, before we proceed with this video, there's one short clip about 1 minute long. And in that video, they showed you how to use your TI-84 to find something that is called the nCr. And this is called combination. In math, it's called combination. We need to know how to use our GDC to find nCr. So please know where to find these buttons, where to click on your GDC. So open up that video that says using TI-84 to find nCr. You can find that video on the class website and then come back to this one. Okay, so please do not proceed unless you know where to find nCr on your GDC. Okay, so I'm gonna continue assuming that you know where to find nCr on your GDC. Okay, so let's begin. So right now what you see over here, that is our Pascal's triangle. And as we know, it keeps on going forever. We can do this all day, right? But in this video, I'm gonna show you guys how do we convert the Pascal triangle using nCr. Okay, so let's begin. So please have your TI-84 handy. We need your GDC for the conversion. Okay, so for the one and the first two rows, I don't need any GDC for that. But starting from the second row, so starting from the third row, sorry, I can convert this. So this is when you need your GDC. So this now becomes the one over here becomes 2C0. The 2 over here becomes 2C1. The 1 over there becomes 2C2. Okay, so I'm just going to write this in red to represent 1. That will give us 2. That will give us 1, which corresponds to the 1, 2, 1 that we have on the left. Okay, now I want you guys to verify with your GDC and see if 2C0, if it's 1, it should be 1. Right? And with the GDC 2C1, that should be 2. With the GDC 2C2, that should be 1. Okay, so I'm just gonna convert all of this, the stuff that I have here, to nCr format. Okay, to the nCr format. So all of this to nCr format. All right, so that's gonna take me a while, and as I'm writing this down, feel free to check these values with your calculator, okay, with your GDC. So let me begin. So the next one I will have. So here I'm done with that one. Now I'm going to be working on this. So that will be 3C0, 3C1, 3C2, and 3C3. The next one, 4C0, 4C1. 4C2, 4C3, 4C4. Okay, so I'm gonna erase some stuff here that I don't need. So just let me pause the video. I think I need more space, so I'm gonna pause the video and make some arrangements here. Okay, I'll be right back. Okay, so I have zoomed out a little bit. So sorry about the handwritings. The handwriting is now a little bit small, but I hope you guys are still able to see it. So I just finished that row there. So I'm going to continue with the The next one will be 5C0, 5C1, 5C2. Well, let me do that again. 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. You can see that with the conversion, the shape of the Pascal's triangle is still there, right? So I got that one done. Let me do the last one here, right? The last one. But this will be 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, and 6C6. And then again, that's gonna continue forever. Okay, so this is it. This is the same Pascal's triangle, but using nCr to represent each value. Okay, so and this is very, very useful. In fact, a Pascal triangle represented using the nCr is actually more useful than the original Pascal's triangle itself. Why? Okay, so now let's talk about why. So we already know that, so things, let's say for example, if I have, say, a plus b to the power of 5, right? Which means because of the power of 5, I'm going to be looking at this 5c something, 5c something, 5c something. And that's that row there, this row right here will give me the coefficients, right? The coefficients when I expand this whole binomial expansion, when I carry out the binomial expansion, right? So what if today I have something, say, instead of 5, I have 15? It is not going to be very practical for us to do this until 15. Right? I'm not going to carry out each individual term for my Pascal's triangle. So instead, that's when the Pascal's triangle in this nCr format is useful. Okay, so I know that if I need to explain something like this, then my coefficients will be, so let me bring this down, let me copy this down a little bit. I said today we are asked to explain, say, a plus b to the power of, let's go with 13, just to save time, okay? I know that the first coefficient is going to be 13c0. The next coefficient is going to be 13c1, 13c2, 13c3, 13c4, 13c5, 13c6, and that's so on and so forth until 13c12 and 13c13. Right. So I can get all the coefficients without having to expand, without having to complete the stuff from this is 6, this is equal to 6, 7, 8, 9, 10, 11, 12. I don't have to worry about what happens in between. I can jump straight to the 13th, the relevant row, right? So here you go. This is the reason why the Pascal's triangle in the nCr format is actually more useful, right? Even though we might still have to figure out, okay, what's 13c0? That would be, that should be a 1. So please take out your calculator and see what's 13c1. And that should give you 13. 13c2, what does that give you? You should have 78. 13c3, 286. Right, so I have a calculator right now. I'm just punching in the values in the calculator, and then you can get all these values with your GDC to help you out. Okay, so I hope you guys understand that they are both Pascal's triangles, but the one that we have right now, the stuff that we did here, that is in terms of nCr, the combination, the representation of the same Pascal's triangle using nCr, and that gives us that allows us to solve questions a lot faster than having to complete the Pascal's triangle manually. Okay. So now let's take a look at one example. Okay, let's look at one example, and you guys will understand, will appreciate this format more. Okay, so let's say today they want us to find the, let's say, the x to the power of, say, 6 term in the expansion of say 4x minus 1 to the power of 9. Okay, find the x to the power of 6 term in the expansion of 4x minus y to the power of 9. What the question is that what this question is basically asking is, if I expand this and I'm gonna get one of the terms will be x to the power of 6, what is the coefficient gonna be? What's the value in front of it gonna be? So that's what they're asking for. That's what they're asking for. Okay. So here my exponent is 9. So I'm gonna start. So I know that my n, so it's gonna be 9cr. Right. So we need to figure out that is. But let's say let's not worry about that for now. Let's just leave it as r. So this is my first term, and this is my second term. So please be careful with the negative. The sign goes with it, okay? So this is my second term. -1 is my second term. So I'm gonna have 9cr multiplied by my 4x. So what does the power have to be so that I get an x to the power of 6? Think about that. What does the power have to be so that I can get an x to the power of 6? I hope your answer is 6. This should be 6. Now, in the previous video, we talked about the pattern of the exponents. So this is my first term. My second term is -1. Make sure you have the negative, and make sure you have the parentheses. So -1 to the power of, so in order for me, right now, the n is 9, and I have 6 is over here. So the -1 should have a power of 3. Right? And we already talked about this in the previous video. Okay? Now, this is the cool thing. Once you have 3 over here, once you figure out the exponent of your b, you can automatically copy that to your r. Okay? So I can upgrade. I'm sort of upgrading my exponent, my expression now. So now that I know I have a 3 over there, this is no longer a variable. That becomes 3. Let me use a different color just to show you that that came from here. All right. So now it's almost done. So if you put in your calculator, 9c3, go ahead and do that. So 9c3 gives us 84. This is 84. Now 4 to the power of 6. Put that in your calculator. That would be 4096. X to the power of 6. Which is good because that's what we want, right? So 4096 x to the power of 6. And -1 to the power of 3 is still -1. And now we just use your calculator to help you out. And that will give me -344,064 x to the power of 6. And since they're asking for the coefficient, find the x to the power of 6 term. So this is it. This is the entire term. that has x to the power of 6 with it. Okay, so this connection here, let me use a different color. Here, where the exponent of my second term, that has a link with the R, the nCr, when you are solving questions. Okay, now I want to point out one last thing. So let's go back to our Pascal's triangle. So let me erase all this. We don't need that. Okay. Remember in the previous video where we talked about the symmetry. So if you take a look here, the symmetry is like 1, I have a 1 there, 3, I have a 3 there, 1, 1, 4, 4, 1, 1, 5, 5, 10, 10, right? So that's the symmetry that we talked about in the previous video. And let's see how does that symmetry appear under the nCr representation. So I will have 1, 3, 3, 1. So this is my 1. You see that this is 3C0 and this is 3C3. Okay. So let me just draw them so that we can see the link. 3C1 and 3C2. Let me just draw them. And in fact, let me highlight something here. I'm not going to highlight the whole thing. I'm just gonna highlight 0 and 3. Okay. And let me use a different color here. So the 3C0 and the 3C3, they're equal. They give us the same value, which is 1 and 1. 3C1 and 3C2, they give us the same value, which is 3 and 3. Okay, so I'm not sure if you see something here. So let's look at the next row. 4C0 and 4C4, they give us the same value. 4C1 and 4C3, they give us the same value. Do you see the pattern here? 5C0 and 5C5. 5C1 and 5C4. 5C2 and 5C3. Okay, so I hope you guys see the pattern here. So let me tell you, if you don't see the pattern, this is it. 1 plus 2 gives us 3. 0 plus 3 gives us 3. 0 plus 4 gives us 4. 1 plus 3 gives us 4. 0 plus 5 gives us 5. 1 plus 4 gives us 5. 2 plus 3 gives us 5. 0 plus 6 gives us 6. 1 plus 5 gives us 6. 2 plus 4 gives us 6. So I hope you guys see the pattern here. Okay? So when over here, if we have 9C3, if you don't believe me, let me write a different color. You can put this in your calculator. If you see 9C3, that will give us the same value, which is 84. There is another 9C something that would also be 84. What do you think that is? That would be 6. Because 6 plus 3 plus 6 gives us 9, right? So 9C6 would also give us 84. And this pattern here is very important when we are solving tougher problems, which I will show you guys in the next video. Okay? Please bring questions to class. Ask me, ask your friends, and I'll see ya. Bye bye.